Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, now I'm going to explain you how to get the construction of the DC machine. Okay, so over here we can see that there is a two poles. Okay, so there are two poles. Okay, so from where we can see there is no north and south. Okay, and over here there is a 4 slots. Okay, when there is a 4 slots and the looping is not a looping. Okay, it's not just one loop, but it has two loops. Okay, there is two loops and there is 4 slots. Okay, so normally we just see like this. Okay, only one. Okay, so now we have two loops, and also there is a another like a parallel like this. Okay, like this, and this also will become 2. Okay, so we just see at this point only. We just look at this this 4 point, which is the conductor. Okay, so this represent is the number of conductor, which is 1 and 1 prime, and 2 prime, 2 prime, and then 3 prime, and 4 prime. Okay, so over here there is a 4 slot, 2 parallel path, and also there is a 8 conductors. Okay, over here you can see the 8 conductors. Where is 8? So over here we look at this, all this point. So 1 2 3 4 5 6 7 8. Okay, we have 8 conductor. Okay, and the connection is parallel. So there is a 2 parallel path. So from this draw we can see that this is a brush 1 and this is brush 2. Okay, so 1 and 1 prime is not parallel. 1 and 1 prime is not parallel, and then 2 prime, and then 1 and then 1 will connect to the 4. Okay, 4 prime, 4, then 3 prime. Okay, so we have 2 parallel path. Okay, 2 parallel path. Okay, as we know that E induced, the E induced. Okay, E induced. Okay, actually is the EA, and it comes from the each conductor. Okay, so this is the conductor, we can say this plus minus, and we have 4 conductors. So for E, and this also become 4E. Okay. Okay, so when we cannot summarize become 8AE because it is the parallel. Okay, so we can say that the EA is equal to 4E. Okay, so this is the E is the induced EMF. Okay, induced EMF in a one conductor, Okay, so this one conductor, just one over here. Okay, one conductor. Okay, so from where we get 4 here, so when we look closely to the 4, so we can say that the 4 actually is the number of conductor divided by the number of parallel path. Okay, so this is the number of conductor divided by parallel path. Okay, divided by the parallel path. Okay, now we look at the how is the we have to do everything over here. So we have 2 number of poles. Okay, and then okay, how if we rewrite again? So we make sure that the number of conductors we assume is as a Z. Okay, Z, and number of pole is pole. Okay, wait, I think it's better we write it again. Okay, so P, number of poles, and then Z is number of parallel path. Number of parallel path, and omega is the angular velocity. Okay, angular velocity. So this is in the radian per second. Okay, so as we know that the induced EMF in the conductor, okay, in a conductor. So this one conductor. Okay, so when we do try to find the voltage induced in the rotating loop, the formula is E is equal to BLV. Okay, so this is in the one conductor. Okay, so to get the EA, so I mean the overall, the EA, so we can say that the number of conductor divided by parallel path. Time with BLV. Okay, so we can say to summarize, we can number of conductor. Wait, there is one more thing. Okay, I think I make a mistake over here. Actually, the number of, this is not Z, this is A. Okay, the parallel path is A. Okay, this is A, and Z is actually is the number of conductor. Okay, so right here is Z over A. I think better we use straight. So Z divided by A with BLV. Okay, as we know that V, okay, V is equal to R omega. Okay, so we can replace Z A B L R omega. Okay, so then what happened in the we want to replace the B. Okay, because it's not meaningful, because the most meaningful formula, or the easiest way, or there's a relationship. Actually, we need to use the phi, okay, or the flux. Okay, so the flux formula is equal to AB or AB. Okay, also okay, okay. I think it's better we write AB. Okay, AB. So the A here actually is number of area of the pole. Okay, so over here to find the value, the area. Okay, the area of the pole. Okay, so this is the rotor, and this is the permanent magnet. Okay, the pole, want to find the area. Okay, we use the rotor area, this area, the cylinder one. So the area is 2 pi r L. Okay, so this one for the area for the rotor. Okay, how about the pole, per pole? Area per pole is 2 pi r L divided by number of pole. Okay, divided by number of pole. Okay, so then we can replace the area first. Okay, we can replace the area first. Okay, so then we replace Z over A. So area 2 pi r, so we have RL over there. So RL is already there. We need to times with the P. Okay, okay, wait. Okay, so now we try to replace. So we try to replace. So we already have L and R. Okay, so what we should do now, we rewrite first the B and also the omega, and then to replace this into the formula, we need to times with pi and 2 pi, P with 2 pi, and then AP. Okay, so then we write Z, again Z, and then we reply B and A. We divide by we replace with this equation. Okay, so we replace the A, B and A. Okay, so we get P 2 pi omega phi. Okay, so from here that we can see that the this one is the angular velocity. Okay, this is the flux, and this is the angular velocity, and then the rest is the construction, the constant of the construction. Okay, so we can write again Z over ZP 2 pi A flux of phi and then omega. Okay, so this is the EA for the any number of parallel path, any number of poles, any number of conductor. Okay, so sometimes we can replace the K ZP equal to ZP over 2 pi A. Okay, and then we can rewrite again like this. EA equal to K flux omega. Okay, and then so this is the induced voltage in the DC machine. Okay, please be noted that sometime some books they will replace the omega here with the another symbol. They write like this: A K phi N. Okay, so N, so since they convert they convert from angular velocity to the RPM, so you need to have a conversion. Okay, so yeah, you need to divide with 2 pi and also N. Okay, so once they convert like this, N equal to omega times with 60 divided by 2 pi. Okay, so this okay, so you must convert first. Okay, so please be noted. So this is in RPM, so this is in RPM, and this is in the radian per second. Okay, so please be noted. Okay, that's all. Thank you.